Okay. Difference in today. So I need your attention, please. Difference in today. If you look at the front whiteboard, so you're using law of sines to solve non-right triangles. So we have been solving right triangles, like I said, using Pythagorean theorem or using SOHCAHTOA. Those methods only work if you have a 90-degree angle in your triangle. So if you do not have a right triangle, you cannot use Pythagorean theorem. You cannot use SOHCAHTOA. That's why today we're covering law of sines, tomorrow law of cosines. Those work when you're given different information. So it gives a little information up here when you would use such a thing. So it says you've used right triangle trig to find the height of trees and other items that are perpendicular to the ground. So again, you have a 90-degree angle. What if an item is not perpendicular to the ground, like a tree that leans due to weather damage? But if you still want to calculate the length of the tree, you can use other forms of trig. So law of sines and cosines are used with non-right triangles. And then I have law of sines given to you right there. So law of sines says, first of all, actually, before I look at that, how the triangle is labeled matters when you're looking at law of sines like this. So notice if you have triangle ABC, so angles are always listed with capital letters, A, B, and C. Sides are listed with lowercase letters. And so side A on the triangle is opposite angle A. Side B is opposite angle B. Side C is opposite angle C. So that's important that the triangle is labeled correctly for this relationship. And law of sines says that these three ratios are all proportional. They're all equal to each other. So sine of angle A divided by side A, that ratio is the same as sine of B over B is the same as sine of C over C. So what you are able to do with law of sines is you're able to set up a proportion, which you learned how to solve proportions in Algebra 1, and we'll review. But you're able to set up a proportion to then solve for something that's missing, either an angle or a side. It does give you here when to use law of sines. Law of sines does not work for every non-right triangle. It only works sometimes. But we use law of sines if you have the measure of or measures of two angles and any side. So you have to have two angles given to you and then any side. So I'm not trying to trick you with anything today where you can't use law of sines, but again, after we cover all of the methods and I just give you a triangle, you want to be able to problem solve what method am I supposed to use. So we're just going to go through some examples. We may not go through all of these because there's a lot of examples on here, but if we look at example 1, so here we're just trying to find the variable, the side that is missing but also labeled. So we're trying to find x in this case. So here's what you need in order for law of sines to work. You need to have whatever side you're trying to find, you need to have the angle that is opposite that side. And then you need to have at least one full ratio. So notice if I were to label my sides, like this is angle A, so this side would be little a. And then I have angle B opposite that. The side that isn't listed at all is side B, and then angle C, the side I'm looking for, which is X, is little c. So you have to have at least one full ratio, meaning you need at least one angle and its opposite side, which we have. We have angle A and side A, and then we have angle C, and we're looking for side C. So I'm going to be setting, based on how this is labeled, these two ratios equal to each other. So I would say sine, I'm just going to write this down first. So sine of A over A should equal sine of C over C. And I can substitute in what I have. So I would have sine of angle A is 97 degrees over side A is 16. is equal to sine of angle C is 21 degrees over side C I don't have, that's my x. Okay, and now I solve this proportion to find x. So reviewing from algebra, how do you solve a proportion, Katie? Yes, cross multiply and divide, or I like to set it up this way so we don't make mistakes. You are cross multiplying and dividing, but I would set the cross products equal to each other and then do the division. So these multiplied together, I'm going to write this product as x times sine of 97 degrees is equal to these, or this cross product, so 16 times sine of 21 degrees. And then I usually type everything in my calculator at once. So you just need to be careful with how you're typing things in, because I know some of you, especially with your calculators, have to type it in a special way. So make sure right now that however you're typing it in, you can get the right answer. Because now to solve for x, I would have to divide by sine of 97. So like I said, I'm going to write my answer up here. X is approximately. I type this whole thing in. Okay, so I would type in 16 times sine of 21, and then I can hit enter. I'm not writing anything down. I leave that answer in my calculator, and then I just hit divided by sine of 97. Enter. So it should be, if I were to round to one decimal place, about 5.8. Okay, so I type in the 16 times sine of 21, enter, divided by sine of 97, enter. 5.8, approximately. Okay, and I know some of you have to type it in a special way. You have to type in the angle and then hit sine. So just make sure that you're able to type it in and get that. Not all calculators work the same. And I'll have you do examples on your own too. So if you are having trouble getting a correct answer, please let me know. Are there questions on that example? Okay, so now looking at example 2, not every triangle you're given is going to be labeled triangle ABC. Okay, law of signs can still work, it's just different letters. So here we have STW. So I'm going to label my sides, so opposite angle S, where I have my X, that would be side little s. Opposite angle T, the 14 would be side T, and then opposite the angle W would be side W. So it's still the angle with its opposite side is what you're looking for. In this case, like I said, we need one full ratio, so we need an angle with its opposite side that we know both of them. Do we have that right now? No. So we have angle S, but we are looking for side S. We have angle W. We don't know side W, and we're not looking for it. We have side T. We don't have angle T. Is there something we could find based on what we're given, Quinn? Yes, we could find angle T by adding these, subtracting from 180, or just subtracting them both from 180. So angle T, the measure of angle T will be 180 minus the 31 minus the 63. So 86 degrees. Okay, so it wasn't given to us, but we could find that. Now we have a full ratio because we have angle T with side T. So that's my full ratio. I'm going to write that down. I have sine of 86 degrees over side T is 14. Okay, and then I need the ratio for the side I'm looking for, which is side S. So then I would have sine of 31 degrees, because that's angle S, over side S I can label as X. And then I solve the proportion. So set the cross products equal, so X times sine of 86 degrees is equal to 14 times sine of 31 degrees. Solve for X, I need to divide by sine of 86. It'll be approximately, so typing this in, I would type in 14 times sine of 31, enter, leave that in my calculator, divided by sine of 86. And to one decimal place, I should get about 7.2. Questions there? Okay. What I actually would like to do is, let's look at example 5. We'll do example 5 and I'll have you do example 6. And I'll pass out the assignment so you can just practice these. So we'll skip examples 3 and 4. Like I said, there's a lot of examples on here. Anything stick out to you about the triangle in number 5? Well, okay, yeah, nothing's labeled. Anything else? There's a 90-degree angle. This is a right triangle. Okay, yep, never go off of how something looks, go off of how it's labeled. It says 90 degrees, so you know it's a right angle because that's given. Whether or not it looks like a 90-degree angle to you. If I give you a triangle, this is important, if I give you a triangle, if I label this angle as 90, this does not look like a 90-degree angle. If I label it as 90, it's 90. You have to go off of what's given, not what it looks like. So this is a right triangle. Now, the fact that it's not labeled doesn't matter. But if I have a right triangle, I do not need to use law of sines. So if I want to find x, how can I find that? Quinn? Or equals 12 over x. Okay, so I heard a couple things. I heard right triangle, you can use SOHCAHTOA. So we have the 80-degree angle here. And we have the 12 and the x. In relation to the 80 degrees, what is the x? X is opposite the 90. I know it's a weird looking triangle. It's the hypotenuse. What is 12? 12 is the opposite. So, yep, it should be sine. That's okay. It should be sine. So this should be sine of 80. Not a problem. Sine of 80. So let me rewrite this. Sine of 80 degrees is 12 over x, opposite over hypotenuse. And then you can solve. You do not need law of sines if you have a right triangle. Okay, solving for x. Solving for x is my first step. Multiply by x. So I have x times sine of 80 is equal to 12. and then I would divide by sine of 80. So x would be approximately 12 divided by sine of 80, so 12.2. Okay, now I would like you to do example 6. Again, nothing is labeled. However, can you label it yourself? Could you label A, B, C wherever you'd like? Yes, and use law of signs. So, or if you need law of signs or SOHCAHTOA. So I want you to do example 6, find x. Mm-hmm.
I have a life question.
What's your question?
So,
You just said 35.
Does what? How you label it? No, it does not matter.